Hi, I'm Trevor May from Mayfly Audio. Today we're going to continue on the cheap Amazon Tweed Deluxe build. Today we'll look at a couple of things. The first is test fitting all the hardware, and the second is stuffing that eyelet, or in this case, turret board. So here we are with everything mounted. I did this off camera to avoid boring you guys, but I do want to point out a few things. As I've gone with belts and tube sockets in both the power amp, rectifier, and the preamp tubes, I thought they were just kind of a little higher quality than the ones that are in the kit. I also went with replacement potentiometers, but the most important thing was power transformer. I decided to go with a Hammond unit. It's got a CSA sticker on it, and it's about almost a pound heavier and certainly taller than the one that came in the kit. As far as test fitting, I was pleased to see that everything fit properly. A special note with regards to the turret board and those 1/4 inch input jacks. If you have them oriented correctly, then these tangs here would touch the turrets on the turret board. This is because of two things. First, they're a little higher because they're turrets instead of eyelets. And also with this turret board, they expect you to mount the board on standoffs instead of flush to the chassis with an insulating piece below it. Now, one last thing, the power inlet. The kit came with this. This is a little snap-in plastic strain relief. Normally, something like this will work fine, but the issue is that the hole in the chassis was way too big for this to fit comfortably and also not allow movement in that power cord. These are meant for industrial applications, so I put that in there and that's gonna do just fine. In fact, I can lift the whole thing up by the power cord and it works great. One last thing before we go and stuff the turret board. All of the hardware that came with the kit was metric. There's nothing wrong with metric, but it's not compatible with the output transformer, the power transformer, the tube sockets, or kind of anything else. I elected to provide my own hardware for this job, all SAE, and fits just perfectly. Here we're on the bench. Hopefully you guys can see that fairly well. I've got my bunch of resistors. I have my wiring diagram. I'm going to be wrapping the leads around the turrets. And by the way, the turrets are very well staked. They're not loose or anything like that, so thumbs up to whoever did that. Even though each one of these is labeled, I'm just going to confirm with an ohm meter that they actually are what they say they are. Yes, that is 68K. 820, 56, 2 watts, 22K, 5 watts, 250 ohms. That is all of them. First off, that 820 ohm. So we run into our first problem. The legs on these are not quite long enough. What to do? We could mount the capacitor on there and then mount this to the capacitor. It makes for changing individual components a little tricky, but it's something you can do. Sure enough, that's plenty of room to mount it to the turret board. Okay, we've got our resistors mounted to our capacitors. That's the way they're going to be oriented. And you can see that I've left some distance between the capacitor and the resistor because resistors get hot, capacitors don't like heat. So you need to give them some space. 820 ohm / 22 microfarad combination here goes in this first position, so right here. And we're just going to put it on with a little S-bend. So we're going to go clockwise this way. Stick it down as far as it goes. Tighten that up. And we're going to go clockwise this way. Make sure it's getting tight. Now I'm going to put this on time lapse and we just blow through the rest real quick. Now, before I solder these down, I'm going to go through with the multimeter and check that I put all the components in the correct place. Now, here's where I deviate from the stock design. I am considering using different value capacitors in certain locations. The 0.1 microfarad capacitors that are used in 4 different spots in this are pretty big. Maybe it would make the tone a little flubby sounding. So what I decided to do was to replace the first 200 nanofarad capacitors with 22 nanofarad variants, and leave the last 200 nanofarad capacitors alone. That's going to be it for today's video. Make sure you like and subscribe, and thanks for watching.